Okay, functions and data analysis fans. Our topic for today, we're going to start our third unit, which is functions and relations. So we're going to do a review of functions, and we're going to talk about some vocabulary as well. Before we start, let me give you your joke of the day. Did you hear about the restaurant on the moon? Great food, no atmosphere. All right, we're going to start with what it means to be a relation. A relation is basically a set of ordered pairs, or what we usually call points, x comma y. So an ordered pair is an x value and then a y value. Now, there are a bunch of different ways to look at a relation. Number one, graph the following relation on the coordinate plane. So one way to look at a set of points is to graph them. So negative 2, 5. Now I'm going to label, it's always x comma y. X comma y. And when we plot the points, so negative 2 comma 5 means we start at 0, 0. We'll go left 2, negative 2, and then positive 5 is up. So there's negative 2, 5. And then we'll do negative 1, negative 3. So x is negative 1. So the x-axis is left and right, left 1, and then negative 3 for y means we go down. Negative 1, negative 3. And also I'll write down the ordered pair next to the point. 0, negative 2, x is 0, which means we're not going to move left or right, and the y value is negative 2. So from the origin, we're not going to go left or right because x is 0, but the y value is negative 2, which means we go down. And there's 0 comma negative 2. Then we have 3 comma 0, so the x value is positive 3, so we're going to go right 3, but up and down is 0. So we're on the x-axis there. And then we have 5 comma negative 3, so x is 5 spaces to the right, that's positive. Negative 3 for y means we go down, 1, 2, 3. So we can represent a relation on a graph. We can also represent it as a table of x's and y's. So we're going to list all the x values, negative 2, negative 1, 0, 3, 5. Negative 2, negative 1, 0, 3, 5. And then the corresponding y values. Now, when x is negative 2, the y value is 5. So I have to put the 5 in this position here across from negative 2. Negative 1, the y value is negative 3. And then negative 2, 0, and negative 3. So we can represent a relation as a table. We can also do what's called a mapping. You have this space on the right. A mapping is two ovals, and we put the x's in the first oval, and we put the y values in the second oval. Now with the y values, notice that negative 3 actually repeats. So when I write these down, I don't need to write negative 3 twice. I'm not going to put negative 3 again. Now for a mapping, what we do is we draw an arrow from the x value to the correct y value. So negative 2, 5, negative 1, negative 3, 0, negative 2, 3, 0. Now the 5 also goes with negative 3, so we'll actually have two arrows going to that value. Now this leads us to a couple of words here, a couple very important words, domain and range. Domain is the set of x values. And the way we would write this, in this example for this relation, we say d equals, the symbol for set is this kind of squiggly bracket here. When you see that, that means set. And then we're going to write all the x values. So I'll use it from the table. Negative 2, negative 1, 0, 3, 5. And then I'm going to close the set. So these are the 5 values in the domain, the set of x values. The range is the set of y values. Domain is x, range is y. We'll use capital R for the range. Normally we'll write the range, like the domain, we'll go from smallest to biggest. So when we look at the y values here, negative 3 is actually the smallest y value, and then negative 2, and then 0, and then positive 5. And again, since negative 3, we had that twice, you only need to write that one time when you write down your range. So that's domain is the x's and the range is the y's. You're going to hear this over and over, so you really want to make sure you understand domain and range. Now, functions. The definition of a function. We're going to write the official definition, and then we'll talk about an easier way to think about it. A function is a situation where for every element in the domain, so for every x in the domain, there exists exactly one element in the range. For every element in the domain, for every x value in the domain, there exists exactly one element in the range for y. Now, as a picture, I'm going to draw a little picture up here. You may have seen this before. If you have, we're going to call this little box here, this is the function, f of x. And what happens, this is the function box. You take an x, you put it into the function, and what's going to come out is a y value. Anytime you put an x into a function, you're going to get some y value. Okay? So it starts with x. X is what we call the input or the domain. You put it into the function, and then what comes out of that is the output or the range. And by definition for a function, for every x value, you can only get one y value. So what happens here, the way that you may have been taught this, x does not repeat. In a function, x cannot repeat itself. That's basically what this whole thing says. X does not repeat. For every x, there is only one y value. Okay, so at the bottom here, number 2, are the following functions? State yes or no. If it's a function, state the domain and range. Okay, so there's really 2 parts to this. In part A, so we have a set of points, a set of ordered pairs. I'm going to label xy, 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 xy. Now we only need to focus on the domain. So just the x values. 5, 1, -3, 0. Notice that they're all different. Now, to be a function, x cannot repeat. In this case, these are all different, so yes, we would say yes, it's a function. Now, because it's a function, we can write down domain. The domain for this would be, again, we'll go from smallest to biggest, -3, 0, 1, and 5. Now, you can have domain as well if it's not a function, but we're only going to write it if it is. The range, now those are the y values, so we have -4, 1, 6, 0. So it would be -4, and then 0, and then 1, and then 6. I encourage you to label xy, xy, just so you don't mix up the numbers. Part B, all right, let's go. xy, xy, do this again. Again, for a function, you're only focused on the x's. If you're trying to determine if it's a function, 3, -2, 0, and 3. Notice that the x's repeat. So what happens is one time I plug in a 3 and I get out a 3 for the y. But the next time I plug in a 3 and I get a totally different value. That is not a function. So we would say no, or you say not a function, because the x does repeat. The y values are allowed to repeat, but x is not allowed to. Okay, so that's the big idea. For every x in the domain, there can only be one y. X does not repeat. So we're going to flip it over. And on the back here, at the top, this is still part of the second question. Now we have three graphs. The question is, are they functions? What is the domain? What is the range? Well, there's a way that we can test this out. It's called the vertical line test. Vertical line test. And what that means is we're going to draw vertical lines. Now in part C, if I draw a vertical line, say here, notice that it intersects the function in more than one place. Now if we write down what the ordered pairs are, this point here is right 2 and up, we say about 3.5. So we could say 2 comma 3.5. We're going to estimate. Now this point is right 2 and down 1. So that's 2 comma negative 1. And then this here would be 2 comma and negative 3.5. Now notice what happens is we have the same x value. If the vertical line hits the function in more than one place, it means that x repeats. And if x repeats, this is not a function. So for this graph, that is not a function. Now if we look at part D, if we draw vertical lines here, well this one only intersects one point. One point. One point. Any way you draw this, it's only going to cross the graph in one place. That means x does not repeat, so yes, that is a function. Now the domain is the set of values of x values that make this thing work. Now here's the thing about domain. How far left do we go and how far right? Notice that this arrow is going to keep, it means the graph will keep going up and it'll also keep going to the left. So I want every x value that gives me a y value on the graph. If I take negative 2 for x, notice that there's going to be a point. There's going to be a y value. If I take 0 for x, there's a y value. If I take 6 for x, there's going to be a y value. It's going to be up here. So from left to right, this is going to keep going left, and it's going to keep going right, and it's going to have every x value will also have a y value. Okay, so we would say the domain is all real numbers. All real numbers. And we can also write that in what we call an interval from negative infinity to positive infinity. Negative infinity is all the way to the left. Positive infinity is all the way to the right. So the domain is all reals. Now we also want to do the range. Range is the lowest to the highest. So if we come down here, how low does our graph get? Here's the lowest point. Range is y values. So the question is, what's the y value at this place? The y value, this is negative 5 right here. So the range, so it goes down to negative 5 and then it comes back up. The arrows mean it's going to keep going up all the way to infinity. So the range is all real numbers greater than or equal to 5. Now the way that we can write that is as an interval. 5 is the lowest and we go up to infinity. So we go lowest to highest. And because 5 is part of that value, I'm going to use a bracket. That means closed. And then this is open. Now we're going to go over this some more. This is called interval notation. So from negative 5, all the way up to positive infinity. From here all the way up. All right, and part E, we'll do the vertical line test. One place, one place. Everything vertical line only goes through one place. Yes, that's a function. Now in this case, the domain, well, left to right, every x value will have a point on the domain. So we're going to say domain is all real numbers, again, from negative infinity to positive infinity. We could also write this as an inequality. Negative infinity is less than x is less than positive infinity. I like interval notation more. Now the range is the y values. Notice the y values are all going to be 3. It's going to be the same. So I'm going to write that as a set because it only contains one value. An interval will have an infinite number of values from -5 all the way up to infinity. This is just one value as a set. And that is the end of part 1.